Alright, let's take a look at evaluating a limit at infinity for the inverse tangent function. Alright, so what we have is the limit as x approaches infinity of arctan or inverse tan of 1 plus e to the x. Okay, and so we start by looking inside this function, and we see that as x approaches infinity, e to the x approaches infinity, so e to the x plus 1 approaches infinity. So what we're looking for is the arctan of something that approaches infinity, or something really big. Now, we could take the approach of looking at the graph of arctan, but I'm going to take the more analytic approach here and try to understand the properties of the arctan function. Okay, so what we're trying to see is that what this means. So this means that the tangent of this thing, or sorry, the tangent of something, so the tangent of what approaches infinity, right? Because if we were to call this theta, arctan results in an angle, then the conclusion from that would be that the tangent, not the arctan, but the tangent of theta would be that number that approaches infinity. Okay, and that's what we're saying exactly right here. The tangent of something, this theta is what we don't know, approaches infinity. So we're trying to figure out what angle this would be. Okay, now I will remind you that this angle does live in a certain place because for arctan to be a function, we have to restrict the domain of tangent. So since we start with arctan, we have a restricted domain. So this guy, this unknown angle, lives in the restricted domain of tangent, which happens to be negative pi over 2 to pi over 2. Now, since we're dealing with limits, it could actually approach one of these two angles. So the limit could equal these even though that number is not included in our domain, right? You can approach a number that's not in your interval. So if we look at a picture of this, let's look at this restricted domain here. See if I can get a good circle here, something like that maybe. The restricted domain, negative pi over 2 to pi over 2, is this region here. Okay? And tangent of something is y over x. And we're approaching positive infinity. Well, tangent's positive up here and negative down here. So we're definitely looking at an angle somewhere up here. Tangent of this angle is really big. So y over x is big, which means x has to be getting small, right? X is getting close to 0. So if you think about right here, where's x getting close to 0? Well, here x is a value, here x is getting closer to 0, right? Here x is getting closer to 0, and you can start to see that x is approaching 0 as our angle approaches what? Pi over 2, right? So the tangent of thetas that approach pi over 2, this tangent value then approaches infinity. In other words, the arctan of numbers that approach infinity is the angle itself that approaches pi over 2. And this is what we want, right? I want the arctan of this thing that approaches infinity equals what? Well, it approaches pi over 2. So the answer to this is the limit as x approaches infinity of arctan of 1 plus e to the x is in fact pi over 2. So just a small disclaimer, this notation here, none of this is technical. I sort of was just trying to help you understand that we're approaching these things. We're not actually equaling them. As I already said, pi over 2 is not even in this restricted domain, yet it is what we're approaching, so it happens to be exactly the limit as x approaches infinity. In fact, we never reach infinity either, right? So this is all about limits and approaching these values and not actually attaining them.